Hi folks, so in the last 10 or so years, whenever you've been graphing something, you've done so with a very particular way. And so let's pretend I want to plot that point. And the way you would get to that point is, well, we imagine that you're starting at the origin, and that's kind of this place that we say, that's where all the points kind of start from. And so you're starting on the origin, you're standing here, and to get from here to your destination, which is right here, destination, you would go left or right some amount, and then you would go up and down some amount. So I'll draw that. So we're walking this way. You're gonna walk 1, 2, 3, some amount here, and we call that whatever that quantity is. We just call that x, and you start off there, and then you turn around. You rotate yourself 90 degrees, I guess we'll say in this case, going upward or vertically. I would imagine that this is a top-down view, by the way, but I can't draw. If I was just drawing a top-down view, you would just be a circle. And then you're going that way, some amount, and that vertical distance that you go is called y. And so the actual location, the way we notate where you ended up, would be with this coordinate pair, this pair of numbers, and we would write in x, comma, y. That's totally arbitrary, and so what we're going to talk about today is another way to do that. And it's hard to see it kind of just looking at it, and so a tool that I have that helps me is my math goggles here. So I'm going to put these on, and when I put them on, things slightly change. So you're still going to see, remember, you're seeing the exact same thing, and you're just looking at it in a different light. So I'm going to put these on, and then we'll see what I see after that happens. Alrighty, so now I have my polar goggles on, and now we see, or my math goggles, although I most commonly use them when looking at this thing called polar coordinates, and we'll talk about what that means when I see this. So again, that point is exactly where it was, and the only thing that changes is my kind of surroundings here. So instead of standing on the origin, I'm still standing on the origin, still standing here, and I'm still starting off looking along the positive x-axis directly to the right, due east if you will. Now instead of seeing, again, this square rectangular grid, I'm looking at this kind of, a bunch of these rings and all these concentric circles. But along the circles are marked out different angles. And so instead of going, well, again, we always like to follow what the road says. So in this land, the road is not split up into very nice grid-like blocks, but the road seems to be kind of all originating out of this origin, and then at different angles. And so the way I'm going to get from here to my destination now, I'll write that here. Again, this is our destination. Again, I'm starting facing the positive x-axis, or what was the positive x-axis. Now if you think back to what we were talking about with the unit circle, the positive x-axis, that's where we indicate 0 degrees, or 0 radians. And the way this works is that I just need to now rotate until I'm looking straight at my destination, and then just walk along until I end up there. And that's exactly what polar coordinates is. And so I'm going to draw that by rotating, starting off from here, rotating some angle, and the way I'm going to indicate the angle is with theta, like we usually do. Now it's going to be a little bit more than that, so right there perhaps, theta. And then once I'm facing the right direction, I'm just going forward. And so I'm going to go out this amount, and the distance I'm going to go out is I'm going to call it r. And the reason we call it r is because you're going out up to a circle, and so that's kind of the radius of the circle. All right, and so the destination before, since we defined it by going left some amount x and then up, left or right some amount x, and then vertically some amount y, and we called it xy, since here we called it an angle and then a distance forward, we're going to denote it as such. So we're going to denote this point r comma theta. Now I'm actually going to be honest with you. I'm at the end of my rope here as to why the order is that way. It would probably make sense to do angle and then the radius, but you can imagine there's no reason we couldn't have simply gone out to the radius first and then walked counterclockwise along that circle up to wherever the point is. So it's kind of just the way it is. Unfortunately, I was not at the meeting to toss my hat in the ring and vote for it to be the other way. But this is how polar coordinates works. Okay, so let's take the polar goggles off and kind of look at everything side by side. Alrighty, so here's our polar coordinates on the left side, and the system, that's what that's called, polar coordinates, right here. What you're used to seeing, and what I'm used to seeing as well, these are called Cartesian coordinates, also called rectangular coordinates, and we're going to use the term rectangular pretty much for the rest of this unit here. So I'm going to say rectangular coordinates. And again, you're just looking at the exact same thing, but from a different point of view, or a different set of lenses, if you will. So the same point would be written, that's supposed to say coordinates. Sorry, it's kind of messy. But with rectangular coordinates, again, you're on a rectangular grid, and so you go left, right, and then up, down. Polar coordinates just means you starting at the positive x-axis, rotate counterclockwise, just like when we were talking about the unit circle. Rotate counterclockwise, some angle, and once you're pointing in the right direction, just go forward. Now note, it's always defined as going forward. Okay, so if you wanted to say go backwards, because you could go just like on the rectangular coordinate grid, you could go forward or backwards or left or right or up or down. You can do the same thing with polar coordinates, and let's just practice that. Let's suppose I wanted to plot the point negative 3 comma 5 pi over 4. 5 pi over, let's do 3 pi over 4. 3 pi over 4. And so what would that look like? Well, I would go out to 3 pi over 4 first. I always do the angle first. 3 pi over 4, so that would be, let's see, 2 pi over 4 would be 1/2 pi over 2. And so 3 pi over 4 would be all the way over here. It's notated for us. And I'm going to go forward in that direction, negative 3 units, so that actually means backwards. And so we've gone there, so that means we're on this ray going that way. But again, negative 3 would be, again, going down this way. So let's notate this. 1, 2, 3, and we'll just say that each of these circles is 1 unit. And so that's what this point would be. This point is at negative 3 pi over 4. Note that this also means that it's a little bit different than rectangular coordinates, because in rectangular coordinates, xy is xy, and there's nothing else. There's no other way to describe it, to describe that destination. You go left or right some amount, and then you go up or down some amount. With this point right here, we could see, okay, if I go out to angle 3 pi over 4, and I go backwards 3 units, then I'll end up here. Alternatively, what else could I do? Well, I could also maybe just go down that much, so that would be a negative angle. That would be an angle of negative pi over 4. Oops. And how far out do I have to go? Well, since I'm facing that direction now, I would just go forward 3 units. And so that point could also be called positive 3, comma, negative pi over 4. Or negative 3 and then another 2 pi around, and so on. So with polar coordinates, you could actually describe a point. There's infinitely many ways. Whereas in rectangular coordinates, you can only do it once. Alrighty? So thanks for watching. That was a little preview of what polar coordinates is and how it relates to rectangular coordinates. Again, really want to emphasize, you're looking at the exact same thing, you're just looking at it with a different lens now. And we're going to see soon the reason for this and what kinds of cool graphs we can get out of graphs defined polarly. Thanks for watching.